Hi all, today we're going to look at another one of the important theorems in mathematics that is known as the Pythagoras Theorem. In fact, this theorem is named after the Greek philosopher Pythagoras. This is one of the important concepts. It doesn't matter what level of mathematics you are doing. It could be GCSE level or advanced level or even higher levels. So then this is one of the important theorems that you have to use in many different times in many different ways. So this could come with several topics actually. It could be quadratics, or it could be geometry, it could be calculus. So then this theorem could be really important. So therefore it is really important to learn. So in mathematics, Pythagoras theorem is a fundamental concept in geometry between the three sides of a right-angle triangle. So we can't use this for any other type of triangles. It is mainly for right-angle triangles. If I name these the sides of this right-angle triangle as ABC, I hope you know that the longest side, the side facing the right angle, is known as the hypotenuse. I hope all of you are familiar with the right angle triangle. So then you can see it here. That means one angle is 90 degrees. So therefore, the other type of triangles like isosceles, equilateral, or scalene triangles are not included. But we can apply to those triangles also in a number of different ways. So we're going to look at some examples how we can apply the Pythagoras theorem in a number of different ways to solve simple mathematical calculations here. Right? The Pythagoras theorem states that the length of the square of the hypotenuse is equal to the sum of the squares of the length of the other two sides. Hope it is clear. It states that the length of the square of the hypotenuse is equal to the sum of the squares of the length of the other two sides. So that means if I try to add these the letters or the length of the sides into the Pythagoras theorem, it says that the c squared, which is the longest side or the side is hypotenuse of the right angle triangle, so a square of that side is equal to the sum of the square of the other two sides. C squared is equal to a squared plus b squared. For example, if we want to calculate the length of the c by knowing the other two sides, we could say c is equal to a squared plus b squared square root. Obviously, we have to put plus or minus here, but since it's a length, we could say it is simply the positive the component only. So therefore, we could say c is equal to a squared plus b squared. Otherwise, if you want to get the length of a by knowing c and b, so we could say a squared is equal to c squared minus b squared. So therefore, a could be equal to c squared minus b squared square root. So hope you know that. So here ABC stands for the length of each side. Right? I hope you know that the hypotenuse is the longest side of a right angle triangle, or otherwise it is the side facing the right angle. Hope it is clear that we can simply connect the length of these the sides into the theorem, and also we can connect angles, the Sokotowa, sine, cos, tan also into this. So therefore, this is a really useful theorem. So let's try to do a couple of examples. So then you can understand how we can just use this theorem to solve simple mathematical examples or questions. So let's look at one of the simplest possible examples for the Pythagoras theorem. So here we have a right angle triangle, and we know the length of two sides actually. So we don't know the length of the hypotenuse, but we know the other two sides, 6 centimeters and 8 centimeters. So then we can apply the Pythagoras theorem. We know that Pythagoras theorem says that length of the square of the hypotenuse is equal to the sum of the length of the squares of the other two sides. So therefore, we can write x squared is equal to 6 squared plus 8 squared. As I said, I'm not going to consider negative part of the square root. So we can write x is equal to 36 plus 64 square root. So then x is equal to square root of the 100. Therefore, x is equals to 10 centimeters. So then that is the length of the hypotenuse of this right angle triangle. So this is one of the simplest examples that we can apply the Pythagoras theorems to determine the length of a side when the other two sides are known. Okay, here we have another example, so which is isosceles triangle. You can see the two sides are having the same length. So this is an isosceles triangle, therefore. So those sides are 7 centimeters in length, and then we need to determine the length of AD. So here we have a right angle triangle. So that means the AD is perpendicular to the BC. So therefore, due to the symmetrical nature of this the isosceles triangle, so we can consider these two lengths OBD is going to be equal to DC. So each is going to be 4 centimeters in length. Hope it is clear. So of course, we can see that BC is 8 centimeters. Since the AD is perpendicular to BC, so then we can determine the BD and DC to be 4 centimeters. Right, okay, so therefore, so this length is going to be 4 centimeters. So then here, what I'm going to do, so then I'm going to apply the Pythagoras theorem. From Pythagoras theorem, we can write that AB squared, which is the hypotenuse of the ABD right angle triangle. So we can write AB squared is equal to BD squared plus AD squared. So we can just substitute the known values. That is 7 squared equals 4 squared plus AD squared. So that means we could write AD squared is equal to 49 take away 16. Okay, so therefore we can write AD squared is equal to 49 take away 16 goes to 33 if I'm correct. Therefore we could say AD is equal to square root 33. Roughly we could say AD is equal to 5.74 centimeters to 3 significant figures or to 2 decimal places. Hope it is clear. So then we have applied the Pythagoras theorem to isosceles triangle to determine the one of the length that we don't know. Right, okay, so here we have another example. So then here we have to determine the length y, which is the length of AB. So we know the length of the two sides and also the one of the angles, which is the angle C. But as you can see, this is not a right angle triangle. So we know that the Pythagoras theorem could be applied only for right angle triangles. So then we don't have a right angle triangle. So then what we can do? So then we can create a right angle triangle. So that's what we can do. So here what we can do, we can draw a perpendicular line to the AC from B. So then it will create a right angle here. So then here we have two right angles. So then we can name this point to be D. Right. So then ABD and BDC are right angle triangles now. So therefore, so we can use the Pythagoras theorem. In fact, for this example, we have to use the trigonometry as well. So that means we have to use secant, sine, cos, tan as well as suitable. So okay, let's see how we can just get the length of the y or the AB. So we have a couple of steps before we get in the length y. To start with, I'm going to get length of BD and also length of DC. Okay, right. So first of all, we'll get the length of BD from BDC right angle triangle. So we can just simply write sine 60. So we have not discussed this yet, the sine cos tan. So, but in another lesson, I'll discuss this as well. So we know that sine 60 is equal to, or the sine is equal to the opposite divided by hypotenuse. Okay, it's opposite divided by hypotenuse. Yeah. So then here we could say opposite of the angle is the BD. Yeah. Okay. So then the hypotenuse is 8. Right, 8 centimeters. So therefore we could say BD is equal to 8 times sine 60. So here you can use a calculator, or otherwise we should know that the sine 60 is equal to root 3 by 2. If you don't remember that, so then you can use a calculator. So then we will get BD is equal to the 4 root 3 centimeters. So I'll leave this without simplifying. So then now we know the length of BD. Right, okay. So then I'm going to get the DC afterwards. So then my plan is to get the length of AD and the BD. So then we can apply the Pythagoras theorems to the right angle triangle ABD to get the length y. Okay, then for the same the right angle triangle BDC, so I'm going to consider cos 60 as well. So we could say cos 60 is equal to the adjacent. So adjacent is DC divided by the hypotenuse, which is 8. So we know that then DC is equal to 8 cos 60. Right. If you know the cos 60, which is half, so 8 times half. So therefore, we'll get DC to be 4 centimeters. Right. So then now we know the length of DC and BD. So if you know the length of the DC, so then we can get the length of AD. So how we can get the length of AD? So then AD should be equals to 10 take away 4. So which is going to be 6 centimeters. Quite easy. So we'll mark this now. So this is 6 centimeters. And then AD we just worked out, which is 4 root 3 centimeters. So then now we know the length. Then we can consider ABD, right angle triangle. If you consider that one, so we can apply the Pythagoras theorem. So we could say that AB squared is equals to AD squared plus BD squared. So we already just determined those two. So it's y squared is equal to AD, we just worked out 6 squared, and then plus, so we got the BD length as well in the previous step, so which is 4 root 3 squared. Right, we can simplify this. So y squared is equal to 36 plus, so you get the square of 4 root 3, square of the 4 is 16, square of the root 3 is 3. So then it is the 16 times 3, which is going to be 48. Then we can determine the y squared is equal to 36 plus 48, which is 84. So then we can get the square root of the both sides to get the y value. Again, we consider only positive the value, which is square root 84. So this is equals to roughly, if you get the square root of 84, so this is going to be roughly 9.2 centimeters. Okay, so now we have the length of y as well. So we knew that we can apply the Pythagoras theorem only for right angle triangles, but here we had no right angle triangle, but we created two right angle triangles, and then we applied the Pythagoras theorem with the sine cos tan here, or the Sokotowa. In here we use sine and cos only. So with that, the trigonometric relationships, we use the Pythagoras theorem to determine the length of y. Okay, so this is how we can use Pythagoras theorem in some mathematical calculations, but this can be applied in numerous mathematical simplifications. Hopefully this was useful to you, and we learned Pythagoras theorem today. Hope you understood the concept here, and then also we did a couple of examples as well. The Pythagoras theorem states that the length of the square of hypotenuse of a right angle triangle is equal to the sum of the squares of the length of the other two sides. We can apply this theorem in numerous mathematical calculations. So if you have any comments, questions, please add into the comment section, so then I can answer accordingly. Okay then, so have a nice time until we meet next time.